proving, which I'm using that word very loosely. We're not necessarily going to write a bunch of proofs. But being able to show that a quadrilateral is a parallelogram. And there's a bunch of theorems, and we could write them out all separately, but I'm not going to do that. We're just going to kind of list. So if you have a quadrilateral, if you have a four-sided figure, you can prove or show or whatever word you want to use there, that that quadrilateral is a parallelogram if, and then there's a few different conditions. One of them, if both pairs of opposite sides are congruent. And that's one of the properties that we looked at the other day, that in a parallelogram both pairs of opposite sides are congruent. So if you have both pairs of opposite sides congruent, it means that the figure has to be a parallelogram. Also, if both pairs of opposite angles are congruent in a quadrilateral, it has to be a parallelogram. If an angle is supplementary to both of the angles that are closest to it. So if we have opposite sides congruent, it has to be a parallelogram. If we have opposite angles congruent, it has to be a parallelogram. If one of the angles is supplementary or adds to 180 with both of the angles that are next to it, it has to be a parallelogram. Also, if the diagonals bisect each other, it has to be a parallelogram. If one pair of opposite sides is both congruent and parallel, so one pair of sides is congruent and parallel, the figure has to be a parallelogram. So these are all the different ways that we could look at. We could look at a quadrilateral, a four-sided figure, and determine whether that shape has to be a parallelogram or not. So when you look at problems like this, you need to look at what you're given, right? In part A, for what value of y must PQRS be a parallelogram? We're given the side lengths, right? So in order for that to be a parallelogram, we would have those two opposite sides congruent. And we would have these two opposite sides congruent. Now, the left-hand equation, 3x minus 5 equals 2x plus 1, is solvable right now. So in order to solve that, I'm going to look at the things that have x's. I have a 3x on the left and I have a 2x on the right. Those have to get combined somewhere. So just because it'll keep things positive, I'm going to subtract 2x from each side. 2x minus 2x gives us 0 on the right. We have 3x subtract 2x, which is 1x, minus 5 equals 1. Since the x is on the left, we want the numbers on the right, so I'm going to add 5 to both sides. So x equals 6. That 6 is ugly. Okay. Now, since x is 6, we can plug that in up here. So 6 plus 2 equals y. So what does y have to equal? 8. Everybody look at the board for a minute. I see your eyeballs. Okay. When you have something like this where you are looking at those two things, this is a problem I saw quite a bit, actually. One of the things that I've seen is that people know, okay, I need to set those two things equal to each other or deal with them in some way. Which is good. I'm glad that we understand that much, but too many struggle knowing what to do with this. So we're going to set them equal, which is where the green equation right here comes from. Okay? You cannot combine numbers that have x's attached to them and numbers that do not have x's attached to them. So this 3 is being multiplied by some number that we don't know yet. This 2 is being multiplied by a number that we don't know yet. The 5 and the 1 are not. So you can't combine those things together on the same side of the equation or anything. What you need to do is get all the x's or all the variable, whatever it happens to be, to one side of the equation by adding or subtracting. Always do the opposite. Get all the variables to one side and then get all the numbers to the other side, and if necessary, divide. Okay. Now the next one gets a little bit more interesting. So in part B, we are given angle measures. Again, to show that it would be a parallelogram, the opposite angles would have to be congruent, right? So 3y minus 2 would have to equal 12x plus 7. And 4x plus 13 has to equal y plus 10. So there's more than one way to deal with the angles because the consecutive angles need to add up to 180, the opposite angles need to be equal. So this is probably an easier way to do it. Now, always pay attention. This is the other thing I've noticed. Always pay attention to where your equal sign is. Okay? If things are on the same side as the equal sign, we're just going to combine them, add them or subtract them as necessary with the